Hello students, I am Dr. Tanmay Bishwash. I hope you all are fine. So, I welcome you all in my channel Chemistry the Mystery of Molecule. So today we will discuss a name reaction, that is a very important name reaction, that is Michael addition. From retrosynthetic point of view, this reaction is very important. And before going to details, I will say this is a continuation of a video I have uploaded about the reactivity of alpha-beta-unsaturated carbonyl compound. As you can see, this reaction contains an alpha-beta-unsaturated compound. So if you have any difficulty in understanding about the reactivity of alpha-beta-unsaturated compound, I suggest please go and first watch that video, after that you come, because it's a sequential way. I believe it's a sequential way of the property of alpha-beta-unsaturated carbonyl compound. So we will learn this reaction. So today's reaction will will cover few points like the basic idea, little bit about alpha-beta-unsaturated carbonyl compound, nature and amount of base, solvent, temperature, etc. And we'll discuss also the mechanism, side reaction, and another important thing, I shall give you an idea about the retrosynthesis, because these reactions are little advanced level reaction. So I believe you, along with the study of this reaction, you also learn the retrosynthesis process. In this way, the very basic name reaction thing will be recapitulated. Second, if you think that you can do it very easily, it's very good. What do I mean? If you can think the retrosynthesis of any molecule, whatever you see, I suggest you please think how to do the retro. It is not essential that in exam this may be asked, but it will increase your understanding and instant knowledge processing capability about organic chemistry. It is very essential, because organic chemistry you can memorize, but through logic and practice you can be expert in this field. So that's why I recommend, whenever you see any molecule, just try to think how this could be synthesized. If you are capable, then whole organic chemistry is in your mind. So you feel comfortable and confident that you can perform better. Okay. So before going to the details, I have a small request. If you really like my teaching, please help my channel to grow. So let's start. As you can see, this is actually a alpha-beta-unsaturated carbonyl compound. Fine. So we know that softer nucleophile attacks the beta carbon. So this is the background principle for this Michael addition. Please keep this statement in your mind. Okay, fine. So first of all this, and second we have to generate this softer nucleophile. And how this softer nucleophile would be generated? Using a base like pyridine. So I think you should learn little bit about the acidity of this compound. See, this is actually a 1,3-dicarbonyl compound. I have already uploaded the synthesis of 1,3-dicarbonyl compound in the retrosynthesis playlist. Please visit if you want to learn more. So this, see, actually this carbon is attached to 2 electron withdrawing group, this ester group, first one. Second, if we eliminate the proton, the conjugate base, which looks like this, is highly resonance stabilized, means because of resonance. This so one canonical form, there is another canonical form also. So so in this way the charge is delocalized. So overall, what I mean to say, that this negative charge is distributed on this oxygen, this carbon, these. So overall delocalized. So that's why this is a delocalized nucleophile. This is a delocalized electron is equivalent to softer nucleophile. If it is, then it will prefer to attack in the beta position. That is the reason why this attack happens on beta position. Secondly, you may think, what is the acidity? Its acidity around 9 to 10. Okay, you may consider this acidity equivalent to, I am saying equivalent to, not exact, nitromethane. Okay, and what is the thing? Such type of weak bases are also capable to deprotonate this molecule as the produced carbon ion is resonance stabilized. So we have understood about the nucleophile, okay, and this beta position is the electrophilic center. Why? Let me give you little understanding. So if you draw the canonical form, so one canonical form is possible like this, means this can come here, it can come here. So this O minus, this is pH, this is the positive charge, and this is the actually electrophilic center for this. It is true that this carbon is electrophilic, but you see the carbon ion produced here is softer. That's why it will prefer to attack this. And keep it in mind, Michael reaction is the addition of this nucleophile on the beta carbon of alpha-beta-unsaturated carbonyl compound. This is the Michael. By the way, instead of this carbon ion, if you take butyl lithium, what is the why the reaction will happen? Selectively here. Okay, because it's a very strong nucleophile and butyl lithium prefers to transfer the alkyl group through a 4-member group. Please keep this thing in mind. If you remember this contradictory statement, then it will be easier for you to understand first of all. Second, to remember two extremes. Okay, fine. Now in this it will attack, it is the electrophilic center. So expected the nucleophile will attack here. So nucleophile will attack on this carbon. This, so means, so whatever this, so ultimately if I remove this, the product will look like this, CH CO2 ET twice. This is dimethyl malonate. Sometimes it also abbreviated as DAM. I am not saying the anion, the parent molecule is named as diethyl malonate or DAM. Find this. In next step, what is expected? See, there is a ethanol reflux. So what can happen? So this charge, first of all, what can happen? It can abstract proton from here also, but logically, I believe, compared to that, the second one is better. What? This is the pH. This is CO2 ET. Now, it can push, it can go. So, this is the minus, this is the carbonyl group. Now see, it is, the carbon is bearing the negative charge. So it is expected that it is more interested to abstract the proton from the solvent molecule, or first of all, otherwise, in presence of these and these, what it resulted? One could be solvent molecule, one could be this. So, but logically, if I say this is more interest to release the proton compared to the ethanol solvent. Okay. So, whatever, whoever supplies proton, ultimately this position will be protonated. So, what is the consequent result? So, this is protonated. Fine. Okay. And this is actually the Michael addition product. Okay. Addition on alpha-beta-unsaturated carbonyl compound, this one. So, this is the overall mechanism. Since I told that this is a versatile reaction, so what versatility could be done, I'll explain slowly. So, we have discussed the mechanism. Now, let's think little bit about the retrosynthesis. Okay, not retrosynthesis. First, let's discuss about the nature of base. See, since these active methylene compounds are strong, better to say, moderately strong acidic, so you need weak base. Weak base is enough for the process. So first point, nature of base. It is better to use weak base. If you want to use, means weak base, what do I mean? You may take NaOH, KOH, amine, etc. Fine. If you take strong base, like you may consider amide, for example, sodamide, tertiary butoxide. So you may think that potassium tertiary butoxide, etc. type, or even sodium hydride you may think. So etc. base if you use, then there is a chance of side reactions will come. So side reaction, for that reason what is prescribed, take less amount. So less amount means around 0.1 or 0.3 equivalent. Now why? See, if you go previously back and see, after this proton was generated, this proton was consumed and the base was generated at the last, because this enolate abstracted the proton from here, so base is regenerated. So it is not essential to use stoichiometric amount base. First point. Second, so if you take this, it is prescribed that solvent should be polar protic. So solvent should be polar and protic. So what is such type of solvent? Ethanol is a polar and protic. And logically, if you react this ethanol plus sodamide, what will be the product? Simple, this OH, this is a strong base, so it will abstract this proton. So ultimately it will result sodium ethoxide, OET minus. So this is also a strong base. Okay, so plus ammonia. But this is weaker compared to this sodamide. Okay, so even if you take tertiary butoxide, similar type of thing you may think. So polar protic solvent needed. Second, temperature should be less. Temperature should be less. Why? Should be less. Like RT, room temperature you may consider. Why? When you are increasing the reactivity of the reagent, means the base, then if you put drastic conditions, side reaction will happen. I shall come to the side reaction. So we have discussed about the nature, amount of base, solvent and temperature. Now what is the problem? As I told, problem is the side reaction. So what are the side reaction? See, what we are dealing a carbonyl compound. Okay, so since it's a carbonyl compound, you are using strong base. Simple thing, what can happen? That aldol condensation, even reverse aldol condensation, one possibility, because I have written here pH. So instead of that, if you think normal CH3, so aldol condensation possible, no problem. First, so one problem, aldol condensation, side reaction. Okay. Second, see, you have taken a ester containing 2 alpha hydrogen and a mild base. So what is that possible? Claisen condensation, or better to say Claisen ester condensation. What do I mean? The anion generated here can attack another molecule ester and result in this. But this is not happening, I'll explain. And third is reverse Michael addition. Reverse Michael addition. What do I mean? That ultimately it can break and come back. Okay, so retrosynthesis part you will understand this. So aldol condensation, I guess you have understood that possibility is that aldol condensation one possible. Second, Claisen ester condensation, but as I told that Claisen doesn't happen if you keep the condition mild. Why? See, if you consider this molecule, for example, instead of that, let's take ethyl acetoacetate, EAA. So anion is generated. This is now question. These anion can react with another molecule of ethyl acetoacetate which is not deprotonated. Point number 1, or this carbonyl, which it will react. First of all, see, the medium is basic, so we can't say that it will not be. Majority of remain in deprotonated state. So if it is deprotonated, this, so it will remain in enolate form stabilized. So consequently, I am not showing that this canonical form, there is another canonical form, but overall the electron is delocalized in this area. Okay, so electron, better to say, is delocalized in this atom. Okay, so it will reduce the electrophilicity. Reduce electrophilicity. Consequently, there is another option. So reaction will happen at this site. Understood? So that's why this is not happen. And reverse Michael addition. Okay, so you may think that this proton is also acidic, so it could be abstracted, this could be generated, or you may think that in this way you may think possible, because the corresponding anion which will come is resonance stabilized. So if the negative charge is resonance stabilized, so it has a tendency to leave. So all these side reaction possible when this thing could be done under relatively dusty condition. By the way, one important information. Please keep it in mind that addition reaction on alpha-beta-unsaturated carbonyl compound, this is thermodynamically controlled reaction. So this is actually, this product is actually thermodynamically controlled. Thermodynamically controlled, or we can say TCP, thermodynamic control product. Okay, so this is because the bond energy of this C double bond O bond energy is higher compared to this. So during the reaction we are consuming a less energy bond compared to this one. So that is the advantage of this process. So this is, now we have discussed the mechanism, side reaction. Now one only thing left, that is retrosynthesis. Okay, so when you, as I told at the beginning, when you study a reaction, it is better to think how would it be prepared. Okay, so if I say it is an alpha-beta-unsaturated carbonyl compound, simple, how to prepare? Aldol condensation. So what will be the corresponding synthon? Synthon could be in this way, it will be broken. So you may think, for example, if you want to do this, so this CH3 C double bond O CH3 plus benzaldehyde. Okay, and if in terms of acid or base, whatever you choose, reaction. Now self condensation will not happen because it's ketone and these do not have alpha hydrogen, so no problem. This is, so this aldol condensation you may read, you may study. I have already uploaded few videos about aldol directed and aldol condensation, directed aldol condensation, etc. So this is one thing. Fine. Now, how to learn the retrosynthesis of product in the Michael reaction? So you may think in this way. First of all, you have to break the bond. So where you can break? Here. So the carbon ion, the retrosynthetic strategy should be CO2 ET, this plus electrophile, pH, this pH, plus charge, and plus charge here. What is the synthetic equivalent? The synthetic equivalent of this reagent is either, you may say, alpha-beta-unsaturated carbonyl compound. Why I am focusing? Because it is very easy to prepare through aldol condensation. You may think the halo derivative also, that's also possible, but always prefer easiest way, because what is the purpose of this retrosynthesis? Purpose that if I need to synthesize any new molecule, how do I think? And the thinking pattern would be based on rational design. Means the reagent synthon could be easily available, reaction is milder, more selective, purification is easier, solvent, temperature, those things should be affordable, means solvent must be safe, cheap, temperature must be low, this thing. So this is the best thing. So in this way you may think about the retrosynthesis. So by the way, one last information, that as I told, reverse Michael, it is also possible. And another thing, in this reverse Michael thing, I am not going to discuss in this video. I will make a dedicated video in future because it's a little complicated story. I don't want to increase the length of this discussion, so I'll stop here. So what we have learned today? We have learned today about the Michael addition, which is carbonyl plus alpha-beta-unsaturated carbonyl compound. By the way, keep it in mind, this Michael addition is a very good way, or you can think it as an application for preparation of different carbonyl compounds. What do I mean? Just I forget to say. So think, you acidify this thing, okay, or hydrolyze. So if you hydrolyze, so what is expected? pH, this is H, CO, pH. Here things will change. So COOET, sorry, this COOET will be converted into COOH and COOH, and we know that 1,3-dicarbonyl compound undergo facile CO2 elimination, and what it will be resulted? So after that it will result pH, this is pH, sorry, this should not be pH, this is the pH, so this is CH2 and another thing COOH. So what is the position? 1, 2, 3, 4, 5. So this is nothing but this is nothing but 1,5-dicarbonyl compound. Why it is important? Because it result in if you take anything nitrogen source like ammonia like that, and it could be converted into 6-member heterocycles. Okay, so 6-member heterocycles. Sorry, I forgot this to mention. That's why at the end I remember. And so 6-member. So in this context, I have already made a video preparation of reading from 1,5-diagonal compound. So this is a strategy to prepare 1,5-diagonal compound. Michael reaction is very selective. And how to think the retrosynthesis? This 2 carbon is from here and 3 carbon is from here. It's a very interesting point you can design. And here I have taken diethyl malonate. Instead of that, if you take ethyl acetoacetate, so in here it will be C double bond OC. So here instead of COH, you will find that COCH3. So no problem, perfectly 1,5-diagonal compound. Okay, so this is the application of this reaction. And another thing, interesting point, as if you carry out the reaction under drastic condition, see, this molecule contains another acidic hydrogen which could be replaced under this basic condition. So not only single Michael addition, this can also undergo and result in di-Michael addition. What? Let me write. What do I mean by that statement? So first of all, carbonyl could be generated here, and similarly, if you take excess of this reagent, if you take excess of this and under drastic conditions, this will again attack, and ultimately what is the final product? Final product, CO2ET, this is pH, this one part, second this is pH, this is pH, this. So it's a di-Michael addition product. An interesting point is that similar way as I told, you can hydrolyze and decarboxylate these 2 parts, or you can reduce into something alcohol. This first of all you need to block this means protect this carbonyl by acetal formation, and lithium aluminum hydride reduction could be done under alkaline condition. So lots of things, and after that you can reduce this carbonyl. So what is left to you? 1, 2, 3, 4, 5, 6, 7. See, this is another interesting point. 1,7-dicarbonyl compound. Why you should learn? You may think, sir, why are you teaching these difficult things? Because, for example, what is the method to prepare 1,2-diagonal compound? You must remember. Oxidation of alpha hydroxyketone, selenium oxide oxidation. How can I remember? In this way, I remember. And I think if you try my way, you can be also expert in this field. What is the 1,3? I have also made video. What is the 1,4? I have also made video about that. Reversal reactivity of active methylene group, then iodine reaction with iodine. One became nucleophile or electrophile. 1,5 this. So 1,6 I'll think and upload you So better way of 1,6 could be this ozonolysis of this double bond. 1, 2, 3, 4, 5, 6. So in this way, you can even oxidize using permanganate, this thing, fine. So I'm not going those details. This is 1, 7. So in this way, everything is in your mind within how many minutes? 5 minutes. Don't worry, I'll make another video regarding this thing so you can understand very well. So this is the application of this Michael addition. Okay. So this is, so what we have learned today, sorry, in between some lots of topic came, I forgot. So first of all, basic idea about the Michael addition. Second, reaction condition, nature of base, nucleophile. Why 1,4 addition? This Michael addition is a 1,4 addition because not only alpha beta, this is 1, 2, 3, 4. This is considered as 1,4 addition. Okay. So this is 1,4 addition, and finally, what is the side reaction? What is the precaution it take? If you do the side reaction, what could be possible? This. What is the synthetic utility? You may think 1,5 darker milk compound preparation. Okay, so this lots of chemistry we have learned today. So thank you everyone for watching this video. I thank you for your patience. If you really like my teaching, I request you please help my channel to grow. First of all, subscribe my channel Chemistry the Mystery of Molecular, and please press the bell icon to get the notification of every single video I upload. Secondly, share this video on your friends so that many people could be benefited, and that will help me a lot because I am uploading this for you people. If many of you people get benefited, that's a satisfaction. And most importantly, for my happiness, I request you, please like the video and make some good comment. It gives a lot of pleasure. And finally, if you think some modification is essential, please feel free to mention in the comment box. I shall try to improve according to I suggest you. Please mention some suggestion how to improve. Then I'll improve and I'll make some better videos for you on a regular basis. Up to that, stay happy. Don't get tense because of this global epidemic. Government, health, medical agency, they are trying their best. Please cooperate with them. Stay happy, stay blessed. See you in my next video.